Today let's solve some problem based on Wheatstone bridge. First you take down the sum, take down the question, then we'll see how to solve it. Calculate the current drawn from the battery in the given network. Question is calculate the current drawn by the battery in the given network. Take down the network. The network consists of resistors marked as R1, R2, R3, R4 and R5. R1, R2. When I say this is R1 equal to 1 ohm, and then we have R2 equal to 5 ohm. Then we have R3 equal to 4 ohm. R5, which is 2 ohm, connected something like this. And R4 2 ohm. And we have a battery connected to this network. The battery is of 4 volt. We need to find out what is the current drawn by the battery in this given network. Let us mark that current as capital I. And to know this current, we first have to calculate what is the equivalent resistance of this combination. So here given is a complicated network. First let us try to understand how these resistances are actually connected. Now if you see, first the network can be rewritten as, the given network is actually a Wheatstone bridge. So let me tell you how we can rewrite this. First start from this point 1 ohm and retrace it. 1 ohm and R5 5 ohm. R5 is 5 ohm. And then we have sorry, I think the values which I have given, no. So R1 is 1 ohm and R5 is actually, this is not 5 ohm, this is 2 ohm. Please correct this. R5 is 2 ohm. R5 is 2 ohm and R2 is 5 ohm, R3 is 4 ohm and R4 is 2 ohm. Okay, now this actually, see, these two terminals are not connected to the battery, but to the battery we have connected these terminals. So let me mark these terminals as A, B, and then CD are the terminals which are not connected to the battery. Now let us say we have terminals A and B, and these two terminals are actually connected to the battery. Volt. If you see this, A and B are the terminals which are connected to 4 volt, and between A and B we have two terminals C and D. Between A and C, 1 ohm resistor is connected. Let me mark C is a point and I am connecting 1 ohm. And between C and D, 5 ohm is connected. And D is the terminal which is not connected to battery. So let me mark D somewhere here. Between C and D, I have 5 ohm. This is R1 and this is R2. And between C and B, what we have? Between C and B, we have R5, which is 2 ohm. Which is equal to 2 ohm. And then between A and D, we have R4, which is 2 ohm. R4, which is equal to 2 ohm. And between D and B, it is 4 ohm. This is 4 ohm, which is R3. Now after you redraw this network, it looks like a Wheatstone bridge. So the given network is a Wheatstone bridge. We have to find out what is this current, capital I. So for that reason, we need to first find out what is the equivalent resistance. First, let us check whether the bridge is balanced or not. Because if the bridge is balanced, the current through CD is 0. The current through this arm, CD arm, or the current through R2 will become 0. So first, let us check whether the bridge is balanced or not. So we need a condition for bridge balance. The condition for the bridge balance is here R1 divided by R5 should be equal to R4 by R3. So let us check whether R1 by R4 is equal to R4 by R3. R1 by R5. So you check whether R1 by R5 is equal to R4 by R3. So this is the condition which is, if this condition is true, then the bridge is balanced. So in the given network, R1 divided by R5 is equal to 1 by 2. So similarly, R4 by R3 equal to 2 by 4, which is nothing but equal to half. So I can write here in the given circuit, R1 by R5 is equal to R4 by R3. So if you see in the given circuit, R1 by R5 is equal to R4 by R3. In the given circuit, R1 by R5 is equal to R4 by R3. Therefore, the Wheatstone bridge is balanced. Therefore, the Wheatstone bridge is balanced. So there will not be any current to the resistor R. So the current through resistor, the resistor which is connected between C and D, resistor R2, in our figure it is R2. The current through resistor R2 is equal to 0 amps. The current, therefore the Wheatstone bridge is balanced, so the current through resistor R2 equal to 0 amps. Now it means that we can remove resistor R2. So the bridge circuit can again be rewritten as only 4 resistors with 4 volt connected. And we have here R1, R5, R4, R3, R4, R3, 1 ohm, 2 ohm, 2 ohm, 4 ohm. Now to find out R equivalent, to find effective resistance or R equivalent. If we see this, 1 ohm and 2 ohm are in series. Similarly, 2 ohm and 4 ohm are in series. And the combination is in parallel. So this again can be written as, this is 1 plus 2. That is R1 plus R5. I'll write here R1 plus R5. 1 ohm plus 2 ohm, which is equal to 3 ohm. Similarly, another one is R4 plus R3. R4 plus R3. Which is equal to 2 plus 4 equal to 6 ohm. And this combination is connected to 4 volt battery. And this is the current I. Now 3 ohm and 6 ohm are in parallel. Therefore 1 by R equivalent is equal to 1 by 3 plus 1 by 6. One by 3 plus 1 by 6, or simplify this, R equivalent as can be equal to 18 by 9 or equal to 2 ohm. Because you take 18 is the common denominator, so that will become 6 plus 3. Therefore R equivalent is 2 ohm. Therefore current in the circuit is equal to I. The current drawn by the battery is equal to V by R equivalent. 4 by 2, which is equal to 2 ohm. Sorry, 2 amps, not ohm, 2 amps. So finally you can write current drawn by the battery is equal to 2 amps. Current drawn from the battery is 2 amperes. Current drawn from the battery in the given network is 2 amps.